have a minute to join. All right, so 1 minute after the start, I think it's a good time. Welcome everyone. I see that only 40% have survived since yesterday. I hope it doesn't have anything to do with the workshop trainer. All right, so today we have very nice list of topics. And again, they come from the Cypress Workshop Basic repository. As always, we'll cover everything in the repository. There are no hidden code snippets or tests that I'm going to teach. And before I begin, I just want to quickly see, does anyone have questions on the material that we covered yesterday? If you do have any questions, just feel free to type them in the chat. I'll keep an eye on that. And I'll keep an eye on questions and answers. Okay, so we covered yesterday introduction to Cypress, how to run it using Cypress Open, how to run it in headless mode using Cypress Run, how to write simple tests, how to add items, how to complete items, how to delete items, all by using scget, cyclic, type commands. And also we covered how to assert that there are 2 items, 1 item, that an element has a class, all those assertions. We also covered a couple of different ways we can reset the state of our database, right, by sending HTTP requests, telling the API, hey, clear the database. We also tried using write file command. We also use cytask to reset the database. But it's very application specific. So you have to plan ahead. How do you allow the test runner to clear the database before you run the test? So today we're gonna cover topics that are super useful, but are a little bit more advanced. So we're going to start with something that I consider an extremely important topic. How do you control the network during your tests? Okay, so let me open the slides. So we'll learn how to spy on network requests. All right, your application will make network requests. It can load static resources. It can make AJAX requests to post data, fetch data. Right, we'll be able to actually spy on all those requests if we want to. We'll also will be able to stop network requests. So the request doesn't go to the server. Instead, it gets intercepted, and then a test response, mock response is sent back to the app. But the app will think that it got that response from the server. Not only we have to do that, sometimes in a test, we'll have to wait for those requests to happen. Right, we'll drive application through the page, but then we'll say, wait for this event, this network call to happen, and only then continue interacting with the page. So we know the data has loaded. And then we'll practice writing assertions against the network calls. So we'll wait for network call to happen, and then we'll grab, for example, the response from the server, and then we'll confirm that the server is sending what we expect it to send. Okay, so let's start. I already started my application, and I'm gonna open the chapter of the test with 05xhr in a folder. Okay. By the way, we're gonna use just the intercept command, which is the new way of spying on a network stubbing. in older Cypress versions, you have to use Cyroute. That's deprecated, so don't even bother learning about it. Okay, so I have my Cypress open right here. I can switch a browser, but I will just keep the list as is with Electron, and I will click on the spec. All right, so our first test, it just confirms that our application starts with 0 items. Okay. Okay, so everything is looking good, but what happens if we add an item or a couple items? So I'll add first, second, and what happens if I rerun the test? So we have a problem right now. We have an assertion, we're getting all the to-dos, and it says there is 0, right? We pass the test, the assertion is green, the task is finished, it's passing, right? We can see the number 1 right here. But obviously we can see the to-dos. So something is wrong. Those two things cannot be true at the same time, right? But they're not true at the same time, right? If you think about this problem, why is the test passing even though we can see the to-dos? You have to look at the sequence of events in your application. So first thing, the page loads, which triggers a load event, right? The web application is making AJAX request, and it actually does this get to dos call, right? So what does it do before that? It shows something. It shows an empty page, right? Cypress doesn't know about the get to dos call, so it looks at the DOM page, sees that there is nothing, the assertion passes. So what happens next? Well, if assertion passes, right, the task is finishing right away, then the network call actually returns and adds those items to the DOM. But by then, it's too late. So these two things, the assertion and to-dos, did not happen at the same time, right? And you can see it by hovering over the command over assertion, right here. Notice that at that moment, the application had no to-dos. And only later, right, the application loaded after the task has finished. So sometimes, in order to understand why the task passed or failed, you have to look exactly at what the sequence of test commands and what the application is doing. Otherwise, things will go unexpectedly wrong. Okay, so how do we fix it, right? You want to confirm that application starts really with 0 to-dos. So the easiest thing is to add wait, right? So let me move this to the bottom. Let me move this to the top. Okay, so we can see both at the same time. So there is a Cypress command called wait, and I'll just say 1 second. Okay, so now the test correctly fails because we actually had some to-dos and we never reset the data. Okay, so we can see that we visited the page. While we waited, it loaded the to-dos. Right, this is the call, right? And then we got the list items. There were 2, and so the assertion correctly failed. If we actually removed everything, then the test would correctly pass. Okay. One other thing I wanted to point out is that the Cypress test, every command is chained and executes one by one, right? So we never had to do then or wait. Visit has to fully finish. Wait will start after visit command finishes. Wait will execute for 1 second. Then the next command starts. Okay. Good. 1 second is nice, but sometimes it could be overkill. Sometimes it would not be enough. For example, is 100 milliseconds enough? In this case, yes. What about 50 milliseconds? Okay, seems like even 50 milliseconds is enough. By the way, how long does this network call take? So if we look at the test while it's running, right? So the initial list fetch, right? Like right here, takes locally only 8 milliseconds, right? So you can imagine that this is very flaky on CI, because on CI, your assumption that it takes less than 10 milliseconds, right? See, this was too short. The test did not fail. 20. Okay, now it fails. Your assumption that the task will take, that network call will take 20 milliseconds or less on CI will be wrong usually, right? Because on CI, all timings are different. On CI, this application might be fetching data from remote server. And so it will happen, whatever the task was doing locally, 20 milliseconds was plenty of time. As soon as you go to CI, it becomes a failing test. Why? Because you would have to, increase the time. Even worse, this test could be flaky, right? So notice right now it passed incorrectly. If I run it again, now it fails. This is the classic definition of a flake. Sometimes the test passes, sometimes it doesn't, right? And there is no way to say when it's going to pass or fail, because it's right at the border in terms of time. So it's very frustrating trying to debug a flaky test when there is a race condition between the application fetching the data and the test runner itself. So what do people do? They try to err on the side of longer waits. And that's how you get tests that should take less than a minute, take half an hour, because everywhere people added, wait 30 seconds, wait a minute, all right, just to be safe. Okay, so what can we do to solve it? We don't want to wait 1 second or 10 seconds or 30 seconds. Instead, what does our task have to wait for? It has to wait for the network call. When the network call finishes, then we should confirm that there are 0 to-dos or 1 to-do and so on. All right. Think about our application right here. Right. Think about the retries, the automatic retriability, right? When the command tries to rerun, right, while the assertion is failing, and if assertion succeeds, then it continues, right? What we talked yesterday. We are observing the page and we're waiting for the element to be visible or become invisible or have a specific class. So we're waiting on observable effect of application behavior on a DOM. The network is exactly another facet or another side of application, right? It's not what is reflected on the page, it's what goes outside the browser to the server. So we really want to wait for the network effect, all right? So here's what I will do. Let's go to the slide. So, and I invite everyone to code with me, right? So we can start with your items, the same test, right? We want to spy on the network call. And you can spy, right? We don't need to do this. We'll just use the same test, okay? So we're not gonna wait. Instead, we'll say, and I'll focus just on this test, intercept get to-dos. Okay. Now, here's a very important point. You know that every command in Cypress runs 1 by 1. So which means the intercept command will run after site visit finishes. But wait, the network call happens during the visit, during initial page load. So if we start intercepting and spying on the network call right here, it's too late. The call probably already went out, so now we'll have a race condition. So if we want to spy on something, we have to set up the spy before that network call happens. So we have to move it before we visit. Okay, I'm going to save it. Okay, so what has just happened? Right, our test still passes it for the wrong reason, right? But now you can see this rec get to dos received. This is a new message, right? If we don't have it, then it's just standard Ajax. But if we intercept it, then it appears. Another thing that you might notice, right, is right here, right above the test body. Take a look again. There is a new section called routes. So every time you add a new intercept, and you can add a lot, will be a route in this table. So right now we're spying on every get request to the route /todos. You can set up, those routes in many ways, right? So look at the intercept documentation. But in this case, we just say whatever is get to /todos, right? Just observe it. Notice we're not stopping it, so we're allowing the network call to happen, right? And this happened once. Okay. If, for example, we let's say reload the page, right here, using site reload. Okay. Notice it happens twice, on the first load and on the second. Okay. So this routes table is very useful because it gives you the details of those network calls. Okay. So the second thing we can do, right, is to set it as an alias. Okay, so here's how it happens. When you set up an intercept, you say as, so like save it as, and let's say load, right? Because this is initial data load. Okay, so again, the UI changed a little bit. We can still see the same route in the table, but now it has an alias. That's how we saved it. And during the test in the command log, notice that this particular call now will have an alias. So you know that this particular request happened at that particular moment. Okay. Now we have to wait for it. All right. By waiting for the network call to happen, we'll make the test wait and only then check the UI. Okay. So not gonna wait 1 second. Instead, we'll say site-wait load, right, using the same alias. So the wait command is pretty interesting, right? It can wait a given number of milliseconds or for the network call to happen by giving it an alias. Okay, so notice now the test correctly fails, right? Because we're visiting the page, it kicks out at some point in time, we don't know when, immediately after timeout, a network call, but we said, hey, test runner, wait for that call to happen. All right. So we're waiting, we can see the application has kicked off that call. Once it finishes, then we assume the network call finishes and then the application immediately renders, right? If application took too long to actually render, that would fail, but our application is pretty fast. So as soon as the network call finishes, it updates the DOM, then we run get to-dos, and we see 2 to-dos, which is not what we expect, right? We expected 0. If we remove them, then application would be correct. We waited for the network call to finish. It has finished, and then we verified the DOM of a page. Pretty slick, right? I think it's very, very powerful. We're literally saying application will make a call at some point, just wait for that call to happen, and then do what you have to do. And we never had to hard code anything. If the call took 5 seconds, right? I believe this wait for the network calls, it has its own timeout of 30 seconds, I believe, by default, so you can actually vary it. But if it took a couple seconds, no problem. The test runner will not fail just because you had the temporary network slowdown on CI. Okay, another comment you might, another question is, how come you did not do something like this? All right, so wait, and then, right, it will work exactly the same, right? In this case, in fact, you can say everything is a then in Cypress. So you can say then, right? You can have a whole pyramid. Every command is automatically waiting for previous commands, so that's why you never have to actually add them yourself. You know, it's all very declarative, right? Think of instructions to the user, right? Visit the page, wait for network call to happen, right? Imagine users has DevTools open, then check that there is 0 items. So you never need to actually do that unless you want to reuse variables. Okay, if we're waiting for the network response, we can actually inspect it. So here's our browser. Let me open the DevTools. All right. I'm going to go to the console, remove everything. So this network call has happened. So let's click on this. All right. This is the network call it waited for. All right. You can see the request, right? What the application sent. You can see the response, right? In this case, an empty body. There was nothing, right? Now imagine we had something. Nice. Okay, if you reload this, right, and if you click on the intercept in this case, then you can see the response, the body has an item. So you can go back in your debugger, inspect each interception, right, see what it has been sent, what cookies have been sent, you know, through the headers, all the things. Very nice. Okay. So in this case, we probably want to confirm, I don't know, like in this case, let's confirm that there is one item, right? So the test passes because the dump has one item, but we can here get its response. Okay. Now, if we again open the DevTools, we waited. That's a big interception object. It has a bunch of properties. One of them is response, right? Which is this one. All right, so this is what we got. All right, this is what the its command yielded. Okay, in this case, we probably want to say body, right? That's what we're interested in. So we can actually combine. We don't have to say it's, right? I mean, we could, right? We can do, you know, step by step. Okay. But in this case, we want to do something like this. Yeah. One thing that you have to watch out, the interception happens outside the browser, right? So when the browser makes a request to do this, right, this interception happens completely in a Cypress application that acts like a proxy, which means that all the caching rules apply. In this case, right, notice that the server is returning an E tag so that the browser can cache it. And notice when the application is making a request, then it sends this hash so that the browser doesn't have to send the new list again and again. So you have to watch out for that. And I believe I have an example where we actually delete this request header. So we get the new response, right? So it It's actually not cached. In this case, we can bypass it by actually removing it and saying something else. Okay. So now we get the actual response, right? Where we get actual body and not 3 or 4, right? So the status code is 200. Then we get the response. Okay. And let's say we're going to delete it again. So what we can do? We don't have to separate. We can just say from the interception, get response, then from that object, get the body property. It should have length 1, right? And what do I want to do? It should be, right? We can even, right? So this yields the actual list, right? So we can say its first element, right? So property index 0, okay? And this will yield an object. So in this case, I'll say should have property, and let's say completed false, right? So we're saying the server should return response with a single item, and the first item will have field completed equals to false. Okay, so we got the network response. Right. We grab its first object and notice it has completed false, right? So we pass the assertion. So this is how we can validate wherever the server sent back by spying on it. Sometimes the server is unreliable, right? Maybe it's busy, maybe it hasn't been written yet, maybe it returns something else, and we still want to test our application. In this case, we don't want to just spy on network. We want to stop the network call. Stopping means we're going to stop the network call so it won't go to the server, right? Instead, a response will be sent back. So in our case, this is an alternative to what we did before, right? Which was reset the data, right? So we can see this right here. Okay. We're going to write this test and we're going to say intercept get to this, and we'll add a third parameter, okay, which is a response. We'll say wait. So here's the third parameter, meaning every time Cypress sees this request from the server, instead of allowing the network call to happen, it will just return this object. In this case, it's just an empty array. Perfect. Notice that request now shows request stub, and inside the routes, we now have yes for stubbed column. So this request never goes to the server like before. So if we look at our server, actually it's inquired. It would not actually show that AJAX request from happening. And now here's the cool thing. We can still add as many requests. They get posted to the server, but when we reload, we don't see them. They are saved on the server, but the initial list is always stubbed. So we always start with 0 items. This is another way, right, which is very simple in this case, but it's enough for application to actually avoid resetting all the data and yet have something that starts in the same state again and again. So we stop the network call, return thing. Okay, so imagine we don't want to hard code this. Okay, we don't want to hard code this particular empty list. So what can we do? Well, we can, inside Cypress folder, there is a fixture. folder, right, by default. And that's where we can put all sorts of fixtures. In this case, we have empty list JSON file. So imagine when this network call happens, we'll say stop that call and return the fixture. Right. So we can say fixture empty list JSON. So we're just giving the file name. Okay. So acts the same way. It just, the list is not hard coded. Instead, it's read from the fixture folder. Now, starting with 0 items is kind of simple, right? You probably want to start with a couple items. You probably want to, in real world application, start with like a user, object, project. So like the page is pre-filled with interesting information, and then you start working with the page, you know, changing things, clicking buttons, and so on. So we want to start with more information. And in this case, I prepared a fixture, right, where there is one item. It's not completed yet. There's another item that's completed. And remember, our application right now doesn't even implement completion, right? So if we do this, this is not saved at all, right? It's completed. But by having a fixture, we can simulate a complex thing that we cannot even recreate through the UI. So in this case, I'm going to say 2 items, I believe. Okay. So now we stop the network call, immediately return 2 items. We probably want to say there should be 2 items. And then we can validate that site contains, right, li. And what is this? First item should not have class completed. And the second item should have class. So we're loading the fixture data on network call. We're waiting for items to be shown, and then we validate how they are shown, that there are expected classes, right, on each item. So that's pretty nice. Okay, so we intercepted the initial load, right? We probably want to see how the items are added, right? Because when an item is added, there is a post request to the same endpoint, so it's a REST API. So we do want to say, check, right, that the item is sent correctly to the server. So here's what we will do. Fixture. Okay, I'm going to concentrate on this. We're going to just spy on the post request. All right, so intercept post to-dos. We're not going to spy. We're just going to save it as an alias. And we're going to visit the page. We're going to add this item. Okay. In fact, we can use both intercepts at the same time. So in this case, I'm going to do this. All right. I'm gonna, I don't even need this. I'll just say yes. Wait, load. Okay. So my application always starts with empty page, and it will wait for it and then post an item. So we have 2 routes that are observed. The first one is a load like before. The second isn't stub, it's a post. Okay. Now let's check out what this sends. Right. So here's what we can do. We want to wait, right, for the post to happen. It does happen. Okay. Now we want to verify, right, that its request actually contains the property. Okay. Now the cool thing is that after we waited, if we try waiting again, this will fail, right? Because our application is not making the second request. So in order for us to get this object again, let's use get. Okay, so the first time network request happens, you wait for it. After it has happened, if you need it again, you do a post, get, and then the Alice, right? And we can verify the other properties. Let's say completed, and it should be false. Okay. We also have another property which we can verify that it exists, but we don't know its value yet, right? It should have property ID. So we can verify that it exists, but we don't know the value. Okay, so in this case, we can just write it as assertion should have property. Okay, now notice that we kind of repeated ourselves a lot, right? So we can write the same thing slightly better, right? We can say should, and then it's, let's say, to do. Now, the should will, like assertion, retry itself. Because it's a single network request, there is nothing to retry. The object is not going to change. So instead of should, we can just say then. Right? So we're waiting for post request. We're getting the body sent by the app. We grab the item right here. And now we can say expect to do. Okay. To deep equal. Now, this is not deep equal just yet, right? Check out what happens. Right, because it actually has additional property. If we open the DevTools and we click on assertion, we can see that we expected to have only two properties, right? And the actual object had an ID. So what we need to do is think deep include. Okay, yes. So to match just a subset of all properties, use deep include. And then we can say expect to do to have property ID, right? And we don't know the value. So this is how you would write a more complex assertions where you validate the network request. Okay. Okay, so we validated this and we have to verify the response, right? Usually we get, right? So what we can do here is get, because it's the same response, same interception, response body, right? And then we can validate it, or check this out, inside the then, right? Then let's say server response. Okay, run this. Cypress again, it flattens the commands, right? So we waited for the network call, we grabbed the body, we ran assertion, then we scheduled more calls right here. So they will execute after this finishes. All right. We got the server response, and what is it equal to? Well, we can write the same assertions, right? They probably will pass. Let's see. Server response, server response. All right, because we know the server is actually responding with the same object. Whatever we send, we get back. Okay, so we can see them passing. Well, in this case, the server response really should deep equal the thing that we sent, right? Which is right here. Whatever we send, the request body, the response body should deep equal the same thing. And it's true. By the way, if you want to see the difference between equal and deep equal, right? Even though the fields in the objects are the same, the values of fields are the same, in JavaScript, if you just compare two things, two objects, it will be by reference. And these are two different variables pointing at two different objects. So they're not deep equal. Usually in the test, you always have deep equal for objects and arrays, because you want to compare each field value by value and not just two variables. Okay, so that's nice. We can write it even better, because all we're doing here is confirming that response body is deep equal to do. So we can say should deep equal to do. And the test still passes. So this is kind of nice. We validating the request from application, the property that are known, and some properties are dynamic, and we'll deal with them in the next section. And then we confirming the response from the server. So think about what we've just done, right? If our server API changes, if the server, for example, responds with just an ID, we'll know our end-to-end test will fail, because we expected those properties to be there. So as soon as it fails, we'll know that API has changed, so we can either go back to the old API because it's unexpected behavior, or we can update our application and all the failing tests, right? So this is a very good type of test, right, to confirm that the network and the server acts the way it used to. Okay, a big bonus for everyone. Cypress has this whole guide on network requests. What should you spy? What should you stub? In general, when you're just starting with front end and you don't have a back end, you have to use stubs, right? Later, when you have a back end, you want to run against it, you remove the stubs, you may be just doing spying on some network requests. At some point, you will find that some of the network calls are either expensive or slow, right? Or go to third-party systems that you don't control. In that case, you want to stop just some network calls. Okay. So I want to finish this section and this hour, actually probably like 5 minutes. Notice in our application, right, when we load the data, there is a very brief flash of content, right? So check this out. So I visit, if we just visit this, okay. I forgot, okay. So check this out, right? If we run it, there is something like loading, like it shows up like in the middle, but it passes so quickly, right? That it's very hard to see. Okay, now we want to make sure that this actually shows up, right? This indicator. So here's what we can do, right? Before we start the visit, we'll say intercept, and instead of just saying get and so on, we can specify all objects, right? I mean, all options using a single object. So URL to this, right? Let's say as load, like before. Okay, so we can see that our intercept is working correctly. And we can say wait load, just to make sure everything works correctly. Okay, now the one thing we can say, I think a response here is an empty list, or let's say fixture. Let's say 2 items JSON. Fixture, no? I can never remember. I forgot the syntax for response. Let's say response, and we'll just pass an empty list. No? Oh, okay. Sorry, wrong thing. So the options for the intercept is the first argument, could be an object, but then whatever you want to respond with, right, is fixture right here. Okay, so think about the first argument being like how you want to filter network requests, and the second argument is how you want to respond if you want to stop it, right? So we're responding with 2 items. Okay, now we can also add a delay. So let's say 2 seconds. Okay, so now we will return the stop, but after 2 seconds. And now we can clearly see the loading element. And so what we have to do, we'll say sci get loading should be visible. Okay, so it is visible, and after the network request finishes, should not be visible. Perfect. So visible here when the network call happens and the loading indicator goes away. It still is present in the DOM, but it's just not visible. Okay, so this is how we can confirm that the loading indicator works. I suggest that you do this case, right? All the edge data that you can set up from the network, right, yourself. Because you have a stubbable network, you can return edge case in data that cannot be created through the page itself, like empty to-dos. And then you see what your application does. Can it handle it? Will it crash? Can the user understand what's happening? Okay, so I want to finish this section with saying that it's super useful for any kind of HTTP REST calls, right, or static resources, right? You can stop all the random data and control it. You can spy on the network calls. So it's very, very powerful mechanism for testing your application. Okay. Any questions for this section before we start the next one? Our next section is going to be even better, I think. Let me kind of go to the, I'm going to jump over application data for now, and I will continue with running Cypress on CI, because I think everyone needs to run the test on CI. You can't just have a test running locally. Okay, so we're going to learn in this section, and just to give everyone a pause in 10 minutes, we're going to take 5-minute breaks in 10 minutes. We're going to cover all the cool things, right? How to run Cypress on CI, how to cache dependencies so the CI doesn't take too long to install everything, how to start Cypress, and then I'll show examples of running actual tests using a Circle CI and GitHub Actions. So let's see. You can set up a free account on Circle CI, right? That's possible, right? And in this repository, I already have a lot of tests that are present, so you don't have to create them in a different folder, right? So our integration contains just the test specs, but I have another folder with a lot of tests, right? But the test UI, access the data in a Vue store, or just do API tests, right, using CyRequest. So we can run both tests on actual CI. So I showed that I'm using Cypress Open to actually work with tests day to day. On CI, you do Cypress Run, which runs tests headlessly by default, but it saves the videos, it runs each spec one by one. So it opens the browser, runs spec, closes the browser. And if there are failures, it will save a screenshot of a failed test, right? So I have another Cypress config file for running on CI so that we don't run the same empty tests. So typically, this is my Cypress JSON, right? On CI, I have a different one that just points at the integration folder Cypress/CI test. So if I want to run on CI in my situation, using different config file. Then I'll do Cypress Run, and I'll say config file with something else. Okay, and I can even do this locally just to demonstrate this. Right, if I do this command, it will load those CI tests from a different folder. Again, excellent. Okay, so notice it's just those 3 files that it found, and then it runs everything, right? Saves screenshots, videos, things like that. Okay, so that's nice. How do we actually run things on Circle, for example? Okay, well, you have to add it on Circle, which starts building it on each commit. Cypress has a lot of documentation on running things on CI, right? Because it's important. So you can see all the things that they suggest in documentation. It's pretty good. You can see how, for example, I have configured Circle CI, right? Here is the whole documentation, right? Or the whole configuration. Some CIs are easier to configure than others. You can configure every CI using Cypress, but for Circle, the Cypress team has written what's called Cypress IO Circle CI, which is like reusable piece of configuration, so that in your workflow, you can say, I just want to have Cypress Run, which is a job coming from this org. And then you just pass parameters like, hey, I want to start a server. So you pass a parameter start, which is optional. You don't have to start the server, right? But on Circle, you want to start the server using command. You want to pass config file, right? You want to store all the videos and screenshots as test artifacts. And then, in this particular case, we don't have any other jobs after that, so we don't have to store any files, which takes a little bit of time. So how does it look on CI, right? If I go to GitHub, and Cypress Workshop Basics, then I have a couple of badges, right? I can click and go to Circle. So this is the Cypress end-to-end test, right? So remember, I only had to do a single job, but under the hood, it expands and it actually checks out code, installs Cypress, verifies it, saves dependencies, npm, and Cypress, and then runs tests, just like I just ran locally. Okay, it even starts the server in a separate background job. And then it uploads the artifact so I can see how the test performed, by clicking on a video, for example. Okay. So all the things are here. So the most important things for CI, right? You need to install everything, right? You do npm install, but you have to cache dependencies. Otherwise, the installation and downloading your production dependencies and dev dependencies, including Cypress, will take a long time. Sometimes you have to start the server if you're running the server locally. So you have to run something in the background. So typically, this is what you would write, right? This is a Circle CI file, which is similar to what you would do on Jenkins, on Travis, and so on, where you would say, well, take all the dependencies. Cypress has a repository and a Docker hub, where it has all Docker images with dependencies, right? You want to check out the code. You probably want to restore previous dependencies by using your package.json file, right? So that whatever you previously installed, you want to quickly recreate. You need to install dependencies using yarn install or npm CI. And after you install, you want to save everything, right? You want to save npm dependencies, and Cypress saves its binary into that cache, right? Otherwise, you'll have to reinstall everything, which takes extra couple of minutes. And now let's start testing. So on Circle, you can start a background process, which will be our npm start. And then you would run our typical Cypress Run command. Right? So this is how you would configure everything on Circle manually. I like to start the server and run Cypress using a single command. So there is start server and test utility that you can use, right? In that case, you just say, npm run CI, starts the server, runs the test, shuts down everything after it's done. So the orb I already have shown, right? This is the simplest case. If you don't want to store artifacts, you don't care about anything, you don't have to start the server. You just say, literally 5 lines of code, just say Cypress Run, and it runs. I showed how we store test artifacts. So on every CI, you probably want to store videos and screenshots, or you can use Cypress dashboard by using true, right? But it's up to you. The cool thing about dashboard, though, is that you can run things in parallel. So, for example, Circle can give you, let's say, not a single machine to run the test, but in this case, let's say by default 4. So you can say run 4 jobs in parallel and split all the specs across. In our case, we have only 3 specs. It's hard to split them across. One machine will always be not busy, so you have to probably use 3 to run all of them in parallel. This is more documentation about Cypress. I really want to quickly show the GitHub Actions, because the GitHub Actions are also very popular, and because it's hosted on GitHub, everything is already for free for public projects. If you go to Actions, you can see the example for this particular repository. This is the test job. It's a single test job, runs in less than 4 minutes, checks out code, runs Cypress tests, runs the answers. All right, you can see everything here that this has been installed, runs the same 3 files. Here's how it's configured. So CI. Okay. This is the whole thing, right? We want to run it on every push commit. We want to use Ubuntu. We could use Mac or Windows. We want to check out the code. And then there is official Cypress GitHub action that takes care of installation, caching, starting things, right? Then you just provide parameters saying, here's my config file. It's not default Cypress JSON. You want to start a server and wait for localhost 3000 to respond. In this case, it's very fast to respond. In our cases, it might take a while for your server to start. So that's why both Circle, Orb, and GitHub Action has wait on parameter. Okay. This is a typical build. That's how easy it is, really. Okay, so my takeaway. Prefer using repeatable builds that use the log files for node, npm CI, yarn install, right? Make sure to cache all the folders where the Cypress is installed, okay? So on Mac, I can say npx cypress cache path, for example, and it will show like where it's cached locally on Mac, okay? So you want to cache that folder so that you don't download and unzip the Cypress again and again. If you cannot start the server for some reason using, specific commands, like on Jenkins, it's like starting a server and then shutting it down is complicated. I have a utility start server and test for simplicity. And make sure you to store the test artifacts, the videos, the screenshots, because otherwise you won't be able to debug what has happened on CI. Another thing that I suggest is Cypress has this example, right? That's what they deploy to example. They have a lot of examples and they actually run them on different CIs, the ones that are configurable, right, and public. So you can actually see the basic configuration, okay, and also how to run tests in parallel so they finish faster. If anyone has any questions, I'll be happy to answer them. Otherwise, let's take a 5-minute break so we can stretch our legs and I can get a drink of water because of talking. Okay, let's take 5-minute break really quickly. All right, how's everyone doing? Let's move to the next section. Let me just close this one. Okay, I think the next important section is to go a little bit deeper into retriability, right? Because once you understand how assertions and commands are retried, you'll be able to write tests that are really flake-free, really dependable, easy to understand, easy to debug, and reliable. So let's open this link. Okay, so we're going to look at assertions, at what's built into the commands already, where you can just use a command and not use additional assertions. And we'll look at retriability under the hood, how you can take advantage of that, and a little bit about data analysis, because that's important. Okay, so I have my application running, all right? And I'm going to use Retriability chapter spec, which is right here. Okay. I'm gonna, what is this? Okay. I'm gonna reset the data so that we don't have problems. And I'm gonna open Cypress. So notice in Retriability, we do reset the data. So we clear the data before each test. So we always start with nothing. We visit the site before each test, right? And our first test is just inserting 4 to-dos and then confirms that there is a list element, not the list item, but the whole list, that contains to-do app. Okay, so let's run this. Retriability. Let's put only on it. Perfect. So we reset the data. We found the input. Right. We did this, insert it, and then we found the UL element. Okay. Right. So what do we want to confirm? We want to finish this test. Right. We want to make sure that this element is visible, the one that we just found. Okay, so we can say should be visible. Okay, it is visible. By the way, so contains has a built-in should exist, right? Assertion, right? Like this is implied. If we didn't find an element, let's say AAA, that's not there, right? But notice the command, right, fails, even if we don't have, like, if we don't have any assertions, right? So should exist is built in into the contains. So we can just say should be visible, right? We want to have confirm that it should have class to-do list. Today, right? So we found the element and we attached 2 assertions. Should be visible, should have class that we expect it to have. Okay. What if we want to, check if it has property, right? So should have. So this is a CSS property. So I believe it should have CSS list style type none, right? Because we don't have, actual dots next to the list items. Okay. And by the way, we can always open DevTools, right? You can always click, right, and look at this element that was found, reveal it in, yeah, it's a little bit tougher here. So let's say inspect element. No, cancel. I probably, because it's a dump snapshot. Okay. But you can always kind of go back because this is live list, right? You can look at what it has, right? You can look at what was that list style, right? You can see like what do you want to assert, right? So we asserted list style type. Okay, so this is easy. I would say, but these assertions, right? So get something should be visible, expect to have props are called BDD assertions, or behavior-driven design assertions. They kind of naturally chain very well, right? So we say get an element and then should have class, should have CSS. We keep working with that element, right? They can take different number of arguments, right? We just saw that there was a single argument should be visible, but if you have a class, you probably want to specify the value of a class that you expect it to have. And for CSS properties, it's the name of a property and the value, right? You can say something like this, right? In that case, it's just, yeah, the property exists. We don't care about its value, but you probably want to specify its value. So this is kind of hard to read. Should be visible, should have class, right? They all have to pass at the same time. So and is another name for should. It's an alias to should. So this is slightly more readable. The page contains to do a list. It should be visible and have class and have list style. Okay, so it's slightly better to read. If you have multiple assertions, to use and. Now, because we configured Intellisense yesterday, if you hover over, should, and it's be visible, it gives you examples of be visible assertion, right? If you hover over have class, then you have an example of have class. And if you have CSS, like the Intellisense understands by first argument, what are you trying to assert, and it will give you a very good Intellisense snippet. If instead you kind of use, expect to have class, right? So instead of should command, or assertion command, if you use BDD assertions like this, expect to have class, then this just comes straight from Chai, and there is no Intellisense because it's not written by Cypress. It's just a library. Cypress does include, test-driven design assertions like assert is equal, assert that equal, assert TP equal, assert is true, but these are very primitive. I don't suggest you use them, right? And it's not as good. Here is an interesting thing. So if you have this kind of assertion, right, you can also write something like this, right? In which case you have a jQuery element, right? And you can say expect L, to be visible, I believe, right? Something like this. So it passes, right? Looks the same in the UI, but because there is no chaining, right? You would have to write a lot of repetitive stuff. Okay, so I prefer, just should and so on. Another subtle mistake is this one, all right? And I hope I have slide about it. Notice here we use .then. So this is, Cypress command .then. Okay. What happens here is that it will find an element, right? And imagine if you have several elements or no elements, it will call .then just once. It will not retry it. You really want to do something like this, because this is a should callback, but will be retried while these assertions are failing. So every time you have assertions inside the callback, think if you want to retry the whole callback, or just end a command that precedes it, or if you want to just do it once. Okay. So I already said that I prefer using BDD style .should callbacks. I really don't like TDD style at all, and in fact, you cannot even do Chai jQuery, Sinon, right, assertions using this way. You have to always just do is true and it doesn't give you UI at all, right? So I can show it that like this one. Okay, notice it just says expect true to be true. What was true? Where did you get it? There is no explanation at all. But I do suggest that you add messages, right? So expect, right? You can have an optional message, right, as an argument. So you can say correct class, for example. All right, so that message will be reflected. For more details you can provide that are visible in a screenshot, that's visible in a video, the better for your testers and users and developers will be. Okay, so I usually have both messages as a second argument. Unfortunately, you cannot give any arguments to the should and end commands. This is how the Cypress command log shows TDD assertions. TDD really very primitive. Okay, so if you have multiple assertions, or if you want to do something very complicated, right? For example, you want to use regular expression, maybe confirm text and process it and split it into words and confirm it, then you want to use should with a callback function and then put multiple assertions there, right? So should can take a callback and you can write complicated logic, right? Maybe even compare a number and from two different elements and say they are the same. Okay, so here's an example. Let's write this. We want to write an assertion where we get all the labels and make sure they all start with to do keyword. So I'm gonna come here. I'm gonna find this test. Okay. So right now we found 4 labels. Okay. So now we just want to confirm with each label, which is a jQuery. Right? So I'll say to probably start with, I'm not sure if this assertion exists actually. You can notice how it actually retries the command, but this invalid. Let's say match, and here I'll use a regular expression. So to do. Oh, because this is jQuery, I believe this is what we have to do. No, not yet. Okay, here's a trick. Open DevTools, go to console, right? And put the debugger keyword. This is real browser. You can stop it at any point. So what does our label have? It has 4 different things. And this is a jQuery element, but it's a collection of actual DOM elements. You can actually hover and see them highlighted, right in the iframe. So what can we do? Right. Well, we can look at the labels and we can say labels 0. Okay, so this is an element. How do we get text from the label? In a text. Okay, so instead of calling text, which is jQuery method, we work with individual elements. So we'll say in a text. So let's run. Perfect. So we confirm the first element, and we could do something like this. 2, 3. Okay, so this is great, but we kind of assumed that there are 4 elements. So we really should have length before we actually go to the next assertion, right? We want to confirm that all these items are present before we start confirming each one. And because this is JavaScript, we can say for var or like let, right, k minus, right, we can say something like this. So we, and this is in a text, and we don't need this function. Okay, well, what happened? Start with to match. Okay. Perfect. So we confirm the number of items is 4 at first, and then that each one starts with the, and we used a combination of BDD assertion and then more complex logic that we have written inside the should call back function. No, if you have dynamic data, right? If you have data attribute that's like, item and then some ID, if you have a class name like that, right? That's where you can confirm it. Maybe you want to get first item, get its value from inner text, then the second item, and confirm the two are the same, but you don't know the actual value. Very nice for tables, all right? Maybe you spy on the network, get the data from the response, and then confirm that each item is displayed on a page. You don't know the values, but you know that every value from the server should be shown. That's a typical use case for complex assertions. This is closely related to retriability, right? So Cypress team really thinks that by running tests in the same window, right, where when the test is running, right, like while this is running, the application cannot run because it's the same window event loop, right? This really cuts and flake because application cannot change the inner text while you're checking it, right? But in order for this to work correctly, you do have to know how commands are retried. Then your test really will be flake free. Okay. So the typical thing, let's say in this example, creates 2 items, right? Let's see if I have this test here. This is logic. Okay, so this one. So this passes, right? We're creating 2 items and we're confirming that the first one is A, and we're confirming that the second one is B, right? Right? In this case, we are visiting a page, which is a command. We grab the focused item, or could be input box, it's a command. We are confirming that whatever we grabbed has a class. Now, this is an assertion. And then we have a couple commands in a row. Command, get the input box, type command, get the li elements, and this is an assertion, right? So you can always check, is it command or assertion? And sometimes you have command, assertion, but sometimes you have command, then maybe one assertion at the end. If you look at the last command, in this case, command and assertion chained, okay? If application is slow, this check, this assertion is not just retried by itself. In fact, Cypress retries command and assertion together. So think of a test. It finishes all commands, assertions, right? And then only the next command can run. So at some point at the end, it will be just the last command, get, followed by assertion. So Cypress will retry this combination of the last command and all assertions attached to it until the pass or timeout. Okay. If you have a command, and like we had before, 3 assertions, this command, then all 3 assertions will be retried. They have to pass all together with that element returned by site contains before the whole thing continues on. So by attaching more assertions, you will make the test stricter. If you have a get and the should callback, Cypress, if there's something doesn't match, it will go back and retry again the get and the whole callback function. And it has to pass without throwing any errors before Cypress thinks, yes, this command was successful. So a command plus assertions, or even the whole should assertion, okay? So this is done to prevent flake, right? Maybe your application is a little bit slow. Maybe it adds items slightly slower, okay? But only some commands can be safely retried. The ones that are only, querying the page, right? Things like get, which finds all elements matching selector. Find, that finds element matching selector from previous elements. It's, remember when we grabbed the object and we grabbed its property. Even invoke is retried. Invoke, if you have an object, can invoke a method. Something that we can do, for example, here, let's say, find label, and then let's say invoke text, which is jQuery method. Okay, so check this out. If you open console, the label element, and then we invoke text, and it just returns the inner text. All right, so this is invoke command. Okay. So these commands will be retried if assertion doesn't pass. Now, things that are not retried are the things that actually change the application. Because if you click on a button, you can't just be clicking 10,000 times until like something happens, right? So some commands are not retried, only the ones that are safe. And a lot of times the commands have built-in retries already. So for example, scget, if you look at its documentation, it has a built-in should exist. Sccontains has a built-in should exist, right? It will automatically make sure there's at least one element. The only other thing you can say is like should not exist. In that case, this built-in assertion is not, is disabled. So I already kind of showed that I said that should will be retried, then just executes once, it doesn't retry, it doesn't go back. Because should is an assertion, right? When we had this complicated thing, let me show this. Okay, so let's say this one. Okay, so in this case, we got the label, right? There were 4 labels. Then we ran those labels, which is a jQuery object, through an assertion. So what's here, like at this point? Right, I can say then console log, for example. So what do you think the console log will print if I open the DevTools, right? So we got 4 elements, they passed through assertion and callback, and then look what's printed. The original result yielded by scget command. Okay, so all assertions like should have length, should call back, they actually pass the original subject, right? Whatever was original result to the next command in Cypress chain. Even if you return something else, like let's say, hello. Okay. The returns from the should callback are ignored because should not change the subject of a command. There are only a couple of exceptions, like should have, let's say, should have attribute, right? Let's say color. These things will change the subject to the value of color, but by default, the assertions don't change the subject. Okay, so I said the save command to retry will be retried. They have built-in assertions, commands like cyclic are not retried, right? So how long does the command retry? Let's say in this case, how long do we wait for, let's say, 6 items? So by default, we wait for 4 seconds. So notice it starts at about 1 second and waits up to 5. So 4 seconds. By default, all commands retried for 4 seconds. You can change this globally, right? You can set it like it's called default command timeout. You can set it in Cypress JSON, right? I don't recommend it because you'll change every command, right? But if your application is slow, you probably might want to bump it up. You can also change it per command. Okay, so let's say you can retry this command up to 10 seconds. Again, we're not modifying how long the assertions can run. They don't understand it. In fact, we modify how long we retry the command. Get command, try assertion. Get command, try assertion. So this is, now we'll do 10 seconds. Maybe our application slow, boom, yeah, slow. How many commands do I need? I need 6. Okay, perfect. So notice we passed the first assertion. Okay. The most important thing to remember, people are caught off guard by this, right? Only the last command is retried because Cypress assumes that when you retry this command, that the previous commands have all finished. They cannot be retried. It's already done. Okay. So only the last command is retried. So here's where it becomes tricky. So I will do the following. So has 2 labels, or has the right label. Has the right label. Okay, this one. Okay, so in this case, we enter the first item, right? And we want to confirm it. So we'll get, let's say, to do, right? And right, to do list li, to do list li, and then we'll find label, should have text, and whatever we entered above. Okay, so this is a confirmation. Perfect. So this works. We entered one to do. We found the label. It's the text we expected. Perfect. So what happens next? We wrote several commands, right? We wrote get, find, and assertion. Okay, it seems good, right? It seems safe. Okay, the next one. Okay, similar idea, only now we'll confirm the first label and then we enter a next label, right? So we'll do this. And at first it will pass. Yeah? What do we have here? To do command. Why is it? Oh. Okay, so everything seems fine, right? We entering the second to do, we confirming it's there. But imagine our application has slight delay, right? Here's where we can, right? So right now we did command, command, assertion, command, command, assertion. Looks very innocent. We can add delay, right? To simulate how application sometimes sends things to the server, right? So I'm gonna open app.js and add to do method, right? Which I believe is right here, right? So right now this sends to the server things and then that's it, right? So imagine I'm adding like a very long delay, right? So if I go back to my application and I say hello, Notice there is 1 second delay before it appears. Okay. Let's say that delay is very short. Let's say 10 milliseconds. Will our test still work? It still works, right? We don't even notice this delay because 10 milliseconds is very slow. What about 20? Still works. 30. Still works. I mean, as a human, you don't notice 30 milliseconds. 40. Still works, no problems. What about 50? Oh, 50 milliseconds, something that's not really visible. Notice it passed, but before it failed. Now it's failing again. Failing. So this becomes really flaky. Okay, now it's passed. So why is this failing? Well, here's the explanation. And let's see if I have it. Use time traveling debugger, right, to understand what happens. So right here, you found all list items. Then you found the label in that list, and you expect label to have to do A, which was true. Now you added another item. So you just add it, right? Notice before and after, it's the same down snapshot because there is 50 millisecond delay. Our test has no idea about the delay. So what it does next, after it typed, it immediately goes to find all the list items. And look what it found. It found just one to do A, right? We added the second, but it hasn't appeared yet. So we found the list. It has only one item. And then we are trying to find, but look where it found, right? It had that list with one item. It searches inside that list for the label, finds the label. It has to do A, right? And this whole operation, right? Find should contain, find should contain. It never sees the full list. It always only considers one list item because that's the one it found. So it searches inside. So it finds, it grabs the list of items and tries to find the label in that list. And so because only the last command is retried, right? Only the last one, right? So finds one item and then it retries again and again. Find the label in that list with one item, never sees the second one appear, right? And fails. Okay. So how do we fix this? Well, there are a bunch of ways. So let me, make sure it fails, for sure, right? 150 milliseconds. So this will always fail. Okay. The first solution, if only the last command is retried, is to use a command that retries the whole thing. So what you can do here, you can do the following, right? You remove a label completely. Okay. So this always passes, and let me actually make it even longer, maybe 1 second long. Okay, so notice in this case, it grabs all the labels and checks if one of them contains to do B, because it goes back to original, find me the whole list. When the second item appears, it will grab it and then confirm it has it. Okay, so this is called merging queries, where instead of separating get, find, you have a single one. Often, if you just want to have an element by text, just say contains. This is even better because it's a single command. So obviously, this will be retried as a single command. Okay, so this is one solution. instead of multiple commands, right? Like command, command, assertion, or command, 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 command. Just have a single command with a bigger query for selecting the elements. Another thing is to alternate, right? So this is an example of merging queries, by the way. Remember how we did its response dot its body? Just merge it into a single access. In that case, it will be retried together, even if an app changes or a model changes or to-dos changes, it will be retried at once, so it will be better. Another thing is not to have command, 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 command assertion, all right? But instead, try to alternate. Always assert that the application has done what you expect it to do by using command, assertion, command, assertion. So in this case, let me just copy paste this. Right, like right here. So instead of whole thing, right, I'll just do this. Okay, notice how it behaves. It always slows down, right? It says command, get me list items. We know that the application is adding to do A, so we will wait until it's there. Then we'll find the label and it should be to do A. We're adding the second to do. So we say, find all the list items before you start doing anything. There should be two. Wait for the second item and then confirm its text. And that's why it waits for the second item to appear before it even starts searching. All right, so type B, wait for the two items to be there. Only then inside those two items, search the label. Okay. So the three things that Cypress can retry. The DOM queries, right? Like finding label. Okay. That's one. The second one, waiting for the network call, right? That's a retry, it just waits, right? When the network call happens, then it will grab that call. So it's not really retrying, it's just waiting correctly, right? And then application methods. I skipped this section for accessing application code, but if you can spy on an application code, right, even like console log, you can say, get me that method spy or stub, and it should have been called once. So that will make the test wait for that method call to be called. So that's another way your application can do something asynchronously, but your test will wait for that to happen, so it doesn't run ahead of the application. Okay, I want to show this because this is important and many people will be tripped up, right? So right now we never saved any values, right? We always like type something, confirm, right? What if we wanted to do I have an ls? Okay, I'll just sort. What if you want to save a value or save an element, right? Here's an example. Okay, we can get a value. Maybe it's from site get, maybe it's from network call, right? Maybe we just want to wrap some value, right? And then we want to say save it, give it an alias. Remember how we saved like network call or interception as an alias? And then inside the test, you can just give me that value. It will be some value. And then you can use it and so on, right? Those aliases are all reset before each test. So instead of using before, which sets it just once, you really want to set every alias that you want to use in the test using before each hook. Like this. Okay. Okay. So that was just the aliases. If everything fails, right? Let's say if we don't separate, if we don't do this, right, the test might fail, right? For those flaky tests, right? So if we had what, like 50, I believe, right? Was really flaky. Let's see, flaky. 45, but sometimes it failed, sometimes it passed. Okay, so this might be a flaky one. Maybe it's 47. Always hard to like find reliably flaky depending on the timing of that. Okay, so this is flaky, right? So this is not the end of the world. This test, if you run it again, probably will pass, right? And it's very frustrating to stop the whole CI run just because this particular element like took slightly longer time. Okay, so here's what you can do, and you can set it globally in Cypress JSON, or my advice is to set it per test. You can say retries, and the number of times you want to retry this test if it fails, let's say 3 times. Okay, so first time, for example, right now it failed, right? Notice it went immediately and ran this test again. You can still see where it failed, inspect everything, but when the second attempt happened and it passed. So this case allows you to actually do not fail the whole CI build on flaky tests, but instead it will be printed in the terminal in Cypress dashboard. So this is passing the first time. Okay, failed. Let's see if it will retry and succeed. Okay, so these are test retries, and you can configure them separately for open mode and run mode. So maybe just on CI you want to finish this, show how it looks and how to enable it. Okay, so the takeaway from this part is that every command in Cypress has some built-in checks, so you don't have to specify every time you want to click on element, oh, it should be visible. Like this check is built in, right? But you can add as many assertions as you want, and it's a good practice. And especially for assertions like DOM, this will retry the command until assertion pass. You can wait for network calls and on application methods as well. But remember, only the last command is retried. So either merge commands, if there are several commands before assertion, or add more assertions so that the test run really doesn't run away and wait for application to do its thing before it continues. And if everything still is flaky, or particular test is still flaky, in that case, then you can add wait like 5 seconds. Maybe your application still start in JavaScript. And if that doesn't solve it, then you can enable test retries per test or per suite of tests or globally, and hope that the test will pass, but you still know that these tests are flaky. Perfect. So I have just a little bit of time to finish with custom commands. Okay, so what we've seen were standard Cypress commands: click, get, type, and so on. You can define your custom own commands, right? Like login. So here's how you do it. You want to reuse code in your test. So we had like reset data, visit site. So how do you reuse this correctly? First of all, this is what support file is for. You can move all those hooks there, right? If every test needs them, you can move those before each hook's there, right? Or load them from a separate hook as well, right? I suggest just make those reusable functions into its own JavaScript file, export, and then import when needed. So in many of my tests, I actually import, right, those functions, and I use them inside the test. It's very simple, right? But these are not custom commands, but these are reusable functions because you can document them. This will create you Intellisense if you use JSDoc. right? So if you hover over enter to do, it works, right? Now, but sometimes you really want a custom command so that everyone can use it. It's in one place. It's not a function, okay? So for example, here's a custom command create to do, and the argument is the text of the to do. So this will replace constantly writing these two commands. Okay, here's how you do it. Cypress.commands add create to do, and then the argument, the text. And then inside you just use normal Cypress commands like get, type. Inside, the test, you can immediately use little side that created it. Okay, now you can make it better because you need Intellisense, right? Here's how you do it. You create a .ts file where you say the big object Cypress now has a new method, and you describe a method. So that's how Intellisense works. And then in your spec files, instead of saying reference types Cypress, you actually point at the custom commands DTS file. Okay. In that case, this is how it looks, right? You will see your JS doc there. Okay, one other thing, you can write things into the command log on the left using scilog command, right? And you can hide individual commands by passing an option. So you don't log them at all, right? Even better, inside the custom command, you can create a log object just for that particular command. So here's where I specify the name, right, of a command, create to do, individual message that will be printed in the command log, and even like what to print when you click on that command, what to print into the console log. And now I hide all individual commands. Okay, so this is how it will look: the name, the message, and when you click on that, it will print the actual thing into the thing, into DevTools console. Another thing that you want to do is you want to take those dump snapshots to show like this was before and after, like to show the final state. And you can actually do this by taking that log object and using an element. So you can highlight specific element on the page and saying snapshot and when it was when you're done. Because imagine you making a very complicated command. Sometimes you can have multiple snapshots to show like before, at login screen, after login, right? You can actually take it and have multiple dump snapshots. And you can pass additional things into the DevTools. Okay. If you want to see actual custom commands and look at the source code or use them, there is a page in Cypress Docs with plugins, and there is a whole section on custom commands, I believe, right? So all these things, right, they provide additional side commands for all the different things. Some of the most useful ones here. Okay. If you're using a third-party library that provides custom commands, usually you have to install it as a dev dependency and just import or require it from your support file so it's available everywhere. And then you start using it. You have to know like what the commands that Cypress XPath, for example, exports. So in this case, lowercase XPath. And when you write custom commands, remember you want to sometimes retry assertions that follow. Here's how you do it, right? You have to look at actual bigger code examples, but you can write a custom command that will retry the assertions that follow it, right? If a user specified any assertions. Cypress pipe is useful for retrying like complicated things. This is a cool one, plugin snapshot, because you want a snapshot like, just snapshot, Ava snapshot. You can actually take the whole object and it will save it in the file if it's the first time it sees it by file name or by spec name. Or the next time it runs, it actually will load the file and make sure that the value matches that file. And another cool thing is that, so this is when the snapshot matches. Another cool thing it can do, I don't have, it can even take image snapshots. So you can take, it will take an image of your application and compare it pixel by pixel to a previously saved image. Though our advanced concept, if you read Cypress documentation, you can write commands that are global, or like parent command, like I don't know, create to do, right? Or you can write child commands that actually need an element. So you'll be able to say sci.get I don't know, toggle, for example. So you write a child command that needs an element to actually do something. And you can also overwrite existing Cypress commands. So you can have your own type, your own contains, right? For example, type that keeps track of all elements you type into. Maybe you want to see if you typed into every input box. And then when you override a command, you will actually get a reference to original command as one of the arguments. So you can actually use the original type if you want to. Okay. So my advice on custom commands, if you want to, I actually start with reusable functions, right? I don't even use Cypress commands that add. I just have my reusable functions, so I can import JSDoc, works right away, and usually it's enough. But when I have complicated commands like sci.login, I usually write it as a custom command. Perfect. We're almost at the end, so I just want to show a couple of slides that kind of summarize what we learned over. When you write end-to-end tests, you really simulate how the user works on the page. The user wants to visit the page, see everything. Before the user clicks on a button, they will scroll to the button. They'll make sure the button is visible. They won't just blindly click on something, all right? And Cypress tries to emulate that as well. It has all the built-in checks. It will run one command at a time, like a real human. It will wait for built-in checks to pass, like the page has to load before it works. The button has to be enabled before it's clickable. The button cannot be occluded by something else, right? You do have to think how the data is set up before each test, because you don't want to have non-deterministic tests that don't really control anything, but rely on previous state. So you want to be able to control the data or stop network to make sure the app looks like it's supposed to. I've shown how to spy and stop on network calls, and look at this section, right? Because we didn't cover it, the how to access application data, but that's one of the unique features of Cypress. From the test, you can access application, changes data, call methods, check values, and so on. And one last thing, when you run Cypress, if you open DevTools, if you can do it from DevTools, you can do it from Cypress, because the code actually lives in the window with your application, just in a different iframe. Okay, so if you can access browser APIs, you can access them from the test, so that you can kind of observe what application is doing. Okay, if you want to learn more, start reading documentation from Cypress. The repo where you can open issues, open discussions to ask questions is there. There is a chat, right, for Cypress users. I sometimes answer questions there. And if you want to, contact the Cypress team, if you have a particular problem with your private account, dashboard, access. There is a support available. And on Twitter, it's there. And if there are no questions, I'll be out of your way. Thank you for listening to me. I hope you practice, right? And you try to run as many tests in each section as possible, right? And thank you for listening to me.